Alright, so today we're going to learn out how to draw Lewis dot diagrams. And we basically have these 5 rules that are on your slides, and we're going to follow each one of these rules and do some examples to really show how to use these rules and get your Lewis dot structures. So let's go over the rules first. First, we have to determine the number of valence electrons. Okay, let's do it with an example so you can see how we're actually doing that. Let's do H2O. Okay, so basically we write down, hey, we've got H in this compound. We have 2 H's, and each H has 1 valence electron. And we can get our periodic tables and see that H is up here. It's got 1 electron in its outer shell. And so 1 electron, which means the total number of electrons from all the H's in the sky is 2 electrons. Now let's do oxygen. Now there's only 1 oxygen. How many valence electrons does oxygen have? Well, oxygen is in the 6A column. Remember, the numbers up here help tell you how many valence electrons it has. So if oxygen is in the 6A column, it has 6 valence electrons. So 6 electrons, which means that oxygen provides 6 valence electrons to this molecule. Now we're going to add those 2 up. 6 plus 2, we get 8 electrons. There are 8 valence electrons in water. Let's try a little different one. Let's try Cn minus. Now Cn minus has all the valence electrons for C and N, but we can't forget it's got a minus sign. The minus sign tells us that it has 1 extra electron over and above the electrons for C, N, and N. So let's go ahead and add those up. Carbon. Carbon, there's 1 carbon, and each carbon runs in the 4A column. So how many valence electrons does it have? It has 4 valence electrons. So we get 4 valence electrons from carbon. Nitrogen, one of those, and nitrogen happens to be a 5A column, so it's going to give 5 valence electrons. We get 5 from that. And the extra electron. If it is a negative sign, we are going to add that charge here. Okay? We should put this up here. Electrons. If it is a plus sign for your charge on your ion, if you're trying to do this stuff for, you would have to subtract electrons. Because remember, the reason why it's plus is it lost some electrons, so you have to subtract some electrons here. We have a negative, so we're going to add the electron. We have 9, and there's 10. This ion has 10 valence electrons. So anytime you're trying to do a Lewis dot structure of anything, first thing is determine how many valence electrons. That's how many dots you're going to put in the Lewis dot structure. If you don't have the number of valence electrons added up at the beginning, you don't know how many dots to put in there. And I've had students do Lewis dot structures, and they're having problems, and I go up and ask them, well, how many dots are you trying to put in? And they don't know. Well, if you don't know where to stop, you can't do the Lewis dot structure. So, know how to figure out how many valence electrons there are in any particular atom. And that's the number of dots you're going to have in your structure. No more, no less. Okay. So let's go on to number 2. Number 2, it says put the least electronegative in the center, and it reminds us that hydrogen always has to be on the outside. Okay. So let's go ahead and do that. We'll work through the rest of this with water. So oxygen and hydrogen. Oxygen is the least electronegative, so we're going to stick it in the center. We're going to put the other guys around our central atom. Okay. Number 3, connect everything to the central atom with a bond, basically 2 electrons. So we've got 1, 2, 3, 4. We've used 4 electrons just to connect everything up. Okay. Then we'll go on to rule number 4. Complete all your octets and keep count of the electrons you're adding. You have to stop at the number you got up here for the valence electrons. So in this case, 8. We need to get up to 8 electrons in this figure, no more, no less. So we've already gotten 4 electrons in that figure just by connecting things up. So we've got 4 more we can add. Now, you might think, well, where do we start adding? Well, first we have to analyze what it looks like and see which ones have complete outer shells and which ones don't. Remember the octet rule. Everything needs A in its outer shell except for hydrogen, which is 2. So let's go ahead and check these guys. We've got hydrogen. We'll count up the electrons available for hydrogen. It's got 1. It's got 2 electrons. So is hydrogen happy? Well, yes, hydrogen is happy. Hydrogen has 2 electrons. It only can have 2 electrons. So hydrogen is happy. Let's look at oxygen. It's got 1, 2, and it's got 3, 4. So oxygen has 4 electrons. How many does it need to be happy? It needs 8. So oxygen needs some more electrons. So let's go ahead and add them. Remember, we're going to always add them in pairs because in this class we aren't dealing with anything that's got radicals or anything like that. So we're always going to add them in pairs. And we're going to keep track of how many we add, counting up from 4. So we've got 4 in there. 5, 6, 7, 8. Now we've reached our maximum. We can't add any more electrons. Let's see if oxygen is happy. We've got 1, 2, 3, 4, 5, 6, 7, 8. Indeed, oxygen is now happy. It's got 8 electrons, so we'll check that off. And now let's check this other hydrogen. It's got 1, 2, and yes, hydrogen is happy with exactly 2. So this is the Leis dot structure of water. Let me just erase those little check marks in there that we used during our creation of it. So we have followed those 4 rules. We never went to rule number 5. So let me go over rule number 5 so that we can understand what it means. We didn't need it in this case, and oftentimes you won't need it. The 5th rule is sort of the last result rule. You only use it as a last resort, and you only use it if you really, really need it. Okay? If you filled in all of your electrons and you've gotten up to your maximum number of electrons, you can't put any more dots in there. But one of your atoms is not happy. It doesn't fulfill that octet rule. Only then can you move your electrons around and form double and triple bonds to try to make them be all your molecules fulfill that octet rule and be happy. Okay. Don't try to put double and triple bonds in from the beginning. It makes it more complicated, and usually then you can't solve the problem. Okay. So let's go ahead and do Cn. We already did number 1. We found it had 10 electrons. Okay. Now we're going to put the least electronegative in the center. There's only 2 atoms here, so we're going to put 1 down and then the other one right next to it. And we need to connect them. That is rule number 3. We're going to connect them with 2 electrons. So we've used 2 electrons to connect them. We still have 8 more that we need to put in the structure to make it happy. Well, obviously carbon's not happy, it only has 2. Nitrogen's not happy, it only has 2. So we need to add some electrons in here. So let's go ahead and do that. We have 2 here. I'm going to try to spread them out to let them cover both of them. So we've got 2. I'm going to count up from there. 3, 4, 5, 6, 7, 8, 9, 10. Well, now we've reached 10. We can't add any more. So let's go ahead and see if our atoms are happy. Carbon has 1, 2, 3, 4, 5, 6 electrons. So carbon is not happy. Remember, carbon needs 8. Nitrogen has 1, 2, 3, 4, 5, 6. Nitrogen is not happy either. So that's where this last rule comes in. Right? We cannot add any more dots to this, but we can move them around. And if neither one is happy the way it is, we're going to have to get them to share some of these electrons. so that then we can get 8 valence electrons for both. So let's go ahead and put the bottom electrons here, and let's say we share those. Okay, let's share those. 1, 2. Now let's look at carbon. It has 1, 2, 3, 4, 5, 6. It's still unhappy because we just moved carbon's electrons there, and it didn't get any help from nitrogen. So let's go ahead and move these guys to the center. Now let's see what we come up with. 1, 2, 3, 4, 5, 6, 7, 8. Oh, carbon's happy now. Yay! Let's go down to nitrogen. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. It is happy as well. So now we've got the Leis structure of Cn. Okay. Now remember, we had this minus sign, so we need to convey to the reader that this is a negative ion. So at this point, we don't know where the negative is on this thing. We don't know if it's on this carbon. We don't know if it's on the nitrogen. So what we're going to do is put big brackets around the whole thing and say, hey, this whole thing has a negative charge. Okay. Later we'll find out where that electron exactly goes in this molecule, whether it's on the C or the N. But right now, we're just going to tell people that, hey, we know this is a negative ion, and the extra electron is on one of those. Okay. So we're going to have additional practices using these sets of rules. So do feel free to work some of these on your own before watching the next video, which will show you some more